Right, so the next part of this, we're going to do the truth table and the Carnot map and stuff for working out what the sum's going to be algebraically. Now, the sum looks a lot more complicated than it actually is. It simplifies to quite a short sum, and you'll see how that works. So, again, we have to start with the Carnot map. So, at the minute, we've got what it is when you add two. Well, if you have a sum of one. So obviously, when you add two ones together, it gives you it gives you a carry of one. So it gives you a carry of one, but you get a sum of 0. But we obviously want it where there's a 1 here. Now there is when you add three ones together, because obviously that gives you a carry of 1, and then it gives you a 1 left over. But we just want ones where there's 1 in this column. So we use the same Carnot map again, and we check if there's a 1 in this column when these things are met. So A, B, C. So when A is 1, B is 1, and C is 1, do we get a 1 in the sum column? Yes, we do, so put an X in it. However, for not, so do we get one when A is 1, B is 1, but C is not 1? Well, no, we don't, so we don't put that in. Not A, B, so that means when A is 0, but B is 1. So when A is 0, B is 1, and then C is 0 as well, so not C. There is 1, because if you look, there's 1 here. However, for the opposite, when C is 1, there is a 0 there, so that's for that. Same for this one. And then obviously not A, B, so that's 0, 0 there. And obviously if there's a 0 there as well, it's going to give you nothing. So for not A, B, not C, there's nothing there. However, for not A, B, and a C, it does give you a 1. So this is the Carnot map for it. So we have to put this in an equation. So you've got not AB, which is this one, but there is a C, so not AB, C in. You've got A, sorry, not A, B, not C, which is this one. I don't know why it does it in that order, but it does. Then you've got A, not B, not C, which is this bit. And then you've got A, B, C in, which is this one here. So we can simplify this even further. So we've got this. Now, well, where do we start with this? Well, the best thing to do is to put a common factor in. Now, the best thing to do is have opposites. So we've got not AB, so C in, because obviously all of them have got C in. So we can take C in out. Well, actually, I say not all of them got C in. Two of them have got C in, and two of them have got not C in. So you take the ones with C in out, so that's not AB and AB, and then the ones with not C in there. So not C in, not A, B, and A not B. So you basically just break this down a little more. Now we can break this down even further, because we know that when you've got opposites, and again check the previous lesson on logic gates for this, but when you've got opposites, so not AB and AB, or opposite in terms of this way as well, so not AB and A not B, so they are opposites of each other again, you get an XOR in the middle, so A exclusive or B. Now, because these are full knots and a full is AB, that becomes not A XOR not B, which is fine. You can do that. That's not a problem. And then you've got not A B and A not B, which just makes A XOR B. So we should have seen this before in the previous lesson. Now again, this simplifies even further, because if you look at it, this one here, so C in not A XOR not B, and this one, that's not C. So that's the opposite of C. And not A XOR not B is the opposite of A XOR B. So these two, so this side and this side are complete opposites to each other, which means it's another XOR. So you can have C in XOR A XOR B. And you might be thinking, well, what does this look like? Because obviously you've got two XORs in there now, so it might be a bit confusing as to where you put your XOR logic gates. And I'm going to go over where that is. It's quite easy in terms of when you actually look at it, you're like, oh, right, this actually makes sense. So you will be able to see how this looks, but I'm going to leave it there. So that's how you do a Carnot map and do the breakdown of Boolean logic for the sum. You just follow it through and just take out things as and when you're going through it, and you will get to the final answer. But that's basically how you do Boolean logic for from a Carnot map if you're doing it for a truth table for the sum of a full adder.